All right. If you were gone on Monday and you're watching this video, here's question 47 and 48. Okay, pause it if you need to. Here's number 49. Okay, very good. Oh, and we graphed them over here. And if you're not sure what's going on, talk to somebody who was here. All right, there we go. So, should have been here. Oh no, I'm sure you had a good reason for not being here. That's fine. All right, this is probably the most important part anyway. All right, so let's talk about the quiz. Let's talk about the quiz. I was trying to think of if there was anything else that came up in the other class, but I don't think there was. Don't really remember there being any other questions or concerns, really. So, on the homework. So if we go through this, you can kind of see how a lot of these kinds of things were involved in today's homework. Some of them weren't. And so as we think about the quiz, I had said that typically there are some things that are going to look very familiar. Like, yes, we did that on the homework. Well, the first one that I listed there in section 1.1, piecewise functions. I told you that's going to be on the quiz. You're going to have a piecewise function. You've got to be able to do a circle equation. You've got to know a circle equation. You also need to know, I guess I could write that in there, the line, the point slope form. We talked about that being important. Okay, so point slope form of a line, we said y equals m times x minus the x point, or a x point plus a y point. So we talked about some lines and some half circles, doing a piecewise function, writing it like so. Promise you'll have to do one of those. We did one in class. Number 12 on your homework in section 1.1 was one of those. So if you want to go back and revisit that, not a bad idea. That's also when we just reviewed the whole idea of function notation, input, output, that kind of stuff. I think domain and range was in that section. Doesn't really matter, but we talked about this idea of domain and range, which of course that is carried forward here in section 3 as well. Which that kind of reminds me, domain and range on a piecewise function. I'll make sure and come back to that. But if, for example, here was that number 12 we did in the homework. This was number 12. So what if we had a picture like this, and I said, okay, now do write the formula for this, right? Write the formula for this. So that's where you need your circle equation, all that. And then what if we also ask, what's the domain and range? What's the domain on this? Yeah, we don't want to say all reals because this one is boxed in. If you have just an XY axis with arrows and the graph has arrows on the end that goes forever, you got negative infinity to infinity, all reals kind of thing. But when it's boxed in like this with no arrows or anything, then we're just going to say negative 5 to 5. I'll try to remind you that probably too on the quiz. But negative 5 to 5. Okay, what about the range? Oh, that's too easy. Okay, you're right. Negative 4 to 2. That's too easy. Let's do this one. Okay? So what's the domain on this one? I meant to do this one. Let's do domain first. Domain is negative 5 to 5 again. Range, negative 4, which would be from here all the way up to there. And then 3. I suppose you can just put brackets around the 3 maybe, right? And it skips. It skips the stuff in between 2 and 3, nothing up here. So negative 4 to 2, and then just 3. Okay, so we can do domain and range in kind of a piecewise kind of a situation as well. All right, anyway, back to this. So that was kind of section 1. Right, just function notation. So if I give you a function and I say what's f of 2, you understand that means you plug in a 2, get the output. Or if I say when does f of x equals 10, that means when the output is 10, what's the input? That kind of, just simple using function notation kind of stuff there. Okay, then we got into section 2, and then that's when the focus was on graphs. The focus there was on graphs and the terminology that goes with graphs. And that's where we learned about local max min, inflection points, concave up, concave down, roots, intercepts, increasing, decreasing. Probably left out something there. And you saw a lot of that on today's homework. Okay, because today's homework was about these different types of functions and then how we can ask all these questions about those types of functions. So they all just kind of mix together. And that's also when we talked about even functions and odd functions and periodic functions. Even functions have what kind of symmetry? Y-axis symmetry. So they're a mirror image on the y-axis, like cosine or like x squared. Odd is origin symmetry, like sine or x cubed. Periodic repeats, but it's got to repeat the y values over a certain period. We had a couple of those homework questions. 23, I think, was one of them. Some of those, I think that was one of them where we'd ask some of those kind of goofy different questions about, remember it was 70 apart, right? You had this one at -30, this one at 40, that was 70 apart, which was 10 periods. So if you want to look over those kind of things, but basically that's what we said about even, odd, and periodic. Okay, and then we go to section 3. Section 3 was then just basically these elementary functions, but you don't have to have them memorized, other than you need to be able to type them into your calculator, and if you're asked a question about one of them, know enough about it that you can set a window so that you can see the thing and you kind of know what you should be looking at. If it's a sine graph, you should kind of know what the basic shape should be. If it's an exponential graph, you should know kind of what it is you should expect to be seeing. If it's a polynomial, a cubic, or a fourth degree, you should kind of know what you should be looking at. So underneath here, I said you should be able to use your calculator at least to be able to put a graph on there, set a window. I don't know how much calculator part you'll need to really do. I don't think there'll be a lot of calculating to do, so there won't be anything really there. Be able to draw a graph, be able to trace on a graph. Remember we talked about what if I give you a problem in context? There's after 10 days there were how many people sick? In that illness kind of problem we talked about. Or at what day were 1,000 people infected? That kind of thing. Be able to read that off of a graph by tracing around and so forth. Okay? I may help you with the window, right? I may help you, like if I gave you this information in the problem, I'm telling you basically the x-min and the x-max, the y-min and the y-max. Okay? But you should also be able to set a window as well. So that's it. Really. There's so those are the basic ideas. So again, you can expect you should look back over that homework. Look back over some of those things that are going to be on there, like the piecewise function and and roots and local max min, inflection points, concavity, all those kind of things. Those terms, even odd functions, periodic. Those are the main focuses. And then there may be a few questions that you have to put it together in a little different way than what the homework question has, and that's just going to kind of get at your understanding of how these things go together. But there's certainly some of that you could look back and review. Okay? All right. So if you think of any other questions you may have, go ahead and you can ask me those. I do plan to give you some work time here. So let's talk about a little bit of trig review. I've been kind of saving this to look at. So if you would pull out, you might want to jot some of this in your notes. Again, this isn't going to be anything you have to have for the quiz tomorrow or anything. And if you would pull out that algebra review packet, the very last page of that algebra review packet that we did the first day. I'm kind of saving the trig part of this for today. And some of this may be helpful in the quiz tomorrow. If you just get more comfortable, more familiar with trig functions, if there's a graph of a trig function tomorrow, you have to graph it on your calculator, you might, yeah. I don't remember. Typically, quizzes are in the 30-point range. Generally somewhere between probably a low of 27, 28 to a high of 40. Typically is the range. Okay. All right. So these are some problems that we have to be able to do. I mean, as early as our very next quiz. Now, are they going to show up on our next quiz? Possibly. I don't know. I'm trying to think ahead. If we get into some trig stuff, there might be. It might actually come up on the next quiz. For sure, probably the one after that, where we have to be able to do some of this without a calculator. Okay? So I'm going to review this with you, give you some time to work on finishing this packet if you don't have these done, and also I've got a few more of these to do. So we want to be able to solve these trig equations. Well, before we can really do that, we've got to have a comfortable handling of the unit circle. Okay, so if you still have memorized it from last year, that's good. Now I do want to review a few key parts of this. So if we go to 30 degrees, okay, now that's pi 6. Well, a couple things I think we ought to remember. I think we ought to remember that on the unit circle, the x and the y is cosine and sine. This is on the unit circle now, right? Cosine is the x, sine is the y. Now the reason for that goes back to SOHCAHTOA, okay? And the definition of opposite over hypotenuse, adjacent over hypotenuse. Another thing you should remember from trig is another way of thinking of tangent is, remember that identity, sine over cosine. Of all the trig identities, you better know that's one of them right there. Because what that means is we can do all the rest of them in terms of sine and cosine. If we remember tangent is sine over cosine, cotangent's a reciprocal of that, secant's a reciprocal of cosine, cosecant's a reciprocal of sine. We can do all 6 if we know sine and cosine. Okay, those things we need to know. We need to know pi is equivalent to 180 degrees. We also got to understand that pi is just a number, 3.14159. Okay, when we say pi equals 180 degrees, that's a conversion factor. That's a conversion factor. Okay, they're not equivalent. Okay, but it's a conversion factor from radians to degrees. This is an equivalence. Pi is just this number right here. So when we say this, we're saying pi radians is equal to 180 degrees. Okay, so those are just some basic things we should know. Now come back to the unit circle. All right, so this means the cosine of pi 6 is root 3 over 2. Now, if you haven't memorized that, okay, how are you going to do that? Well, what you better memorize then is let me go back. Time out. Let me go back to my other page here. Here's one more thing you better memorize. If you haven't memorized your unit circle values, then you better memorize a 30-60 triangle. Pi 6, which is 30, and pi thirds up here, which would be 60 degrees. This is going to be 1/2 over here. This is going to be square root of 3 over 2 here, and this is going to be 1 here. You better have that memorized. 45/45, which is pi fourths and pi fourths. That is root 2 over 2, root 2 over 2, and 1. You better know those triangles, because those triangles can then help you get all of the values around the unit circle that you need without memorizing. You just memorize those 2 triangles. Okay, just remember 1/2 is the smallest, it's across from the smallest side. Root 3 over 2 is like 0.78 something. That's across from the 60, and then the 1 is the biggest side, it's the hypotenuse. So if you memorize those, you should be able to do the rest of this. Okay? Because what you can do here is, if you know this is a 30, you can say, okay, this is a 1/2 over here, this is root 3 over 2 here, and then you can, since you know that's pi 6, and now you can do SOHCAHTOA. So sine would be opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be 1/2 over square root of 3 over 2, and those would cancel, which would be 1 over square root of 3, which also could be written root 3 over 3, so that'd be tangent. But if you remember cosine and sine, you can always remember tangent by just dividing sine divided by cosine. Yes?
So when we're doing these in the test, do you want us to flip that?
I would actually accept either one of those. Yes, either one of those is fine. Okay? I don't think you should leave 1/2 over square root of 3 over 2. I think you ought to simplify that. but either one of those is fine. Okay? Actually, same with square root of 2 over 2. What's the other way to write square root of 2 over 2? That's that. That's the same as root 2 over 2. So those are okay also. Okay? But anyway, so that's pi 6. So if you don't have every one of those memorized, you can draw your triangle in there and put those numbers on it, and then use opposite, hypotenuse, adjacent over hypotenuse and stuff to get them. All right. If you want some extra practice on this, I do have another video on the website. It says Trig Review. So it's got some more of this, what I'm talking about today. And if you just want to come in and sit down with me and have me go through it with you, I'd be glad to. Okay. As we work our way around, here, 45 or pi fourths is root 2 over 2. Okay, pi thirds is here. And then, of course, then you get to the ones that are right here, like at 90 pi halves. Okay, now you get that. Now it's best to remember cosine is x and sine is y. So cosine of 90, cosine of pi halves is 0, sine of pi halves is 1. -1, and that's 1, 0. Okay, now, the other thing on the unit circle we should make sure we can do. We need to know that, okay, this is pi 6, this is pi fourths, and this is pi thirds. And of course, if this is pi halves, let's go all the way around. This is pi halves, that's pi. This is 3 pi halves, and this is 2 pi. Now, when we go around pi 6, okay, pi fourths, pi thirds, what's this one here? 4. What's this one? That's 2 pi thirds. Okay? 60 is 1 pi third. 120 is 2 pi thirds. This would be pi thirds, which would also be 3 pi thirds, is a way to think about it. I'll show you why that's important here next, because this is pi thirds, that's 2 pi thirds, this is 3 pi thirds, so what's this? Actually this. 4 pi thirds. You're 1 pi third past 3 pi thirds. And then the next one over here, 5 pi thirds. And then around the 2 pi, which is the same as 6 pi thirds, right? And then you're around the circle. Okay, pi fourths. This would actually be 2 pi fourths. What's this one? 3 pi fourths. This is the same as 4 pi fourths, 5 pi fourths, 6 pi fourths, I won't write it, 7 pi fourths, which you're 1 pi fourth short of 8 pi fourths, is the same as 2 pi, right? So if you think of these things as fractions, it helps a little bit. Okay, pi 6, this is actually 2 pi 6, this is actually 3 pi 6, this is actually 4 pi 6, this one is 5 pi 6, or a way to think of it is your pi 6, this right here is pi 6, short of 6 pi 6, right? Pi is 6 pi 6. Okay, this would be 7 pi 6, this is actually 8 pi 6, this is actually 9 pi 6, this is actually 10 pi 6 right here, 11 pi 6, and 2 pi would be the same as 12 pi 6. All right, so all this business with fractions and whatnot, being able to know your way around the unit circle. The pi 6 ones are closer to the x-axis, pi thirds are closer to the y-axis, however you want to memorize it, but we need to know that. All right, so if we can do this, that's going to go a long ways towards doing the those problems we want to do in that packet. All right, let's move on then. One last thing I want to show you, and then we'll do a couple of problems. I want to talk to you about the unit circle as it compares to this. And I think Mrs. Payne showed you this last year. Okay, so, all right. All right, so on the unit circle, we said that the y value is the sine. So when I go around, oh, and I should mention this. What is radian measure? Y is all the way around the circle 2 pi. Why is that? Why is this 2 pi when we go one time around the unit circle? Goes back to geometry. That's right. The circumference of a circle is 2 pi r. What's the radius of our unit circle? 1. So therefore, the circumference is 2 pi. So now, it's important you understand this. An angle is a rotation. A radian is an arc length. So when we talk about pi equals 180, what we're saying is 180 degrees of rotation is equal to 3.1, pi, or 180 degree rotation is equivalent, you got to look at the blue here, is equivalent to 3.14 arc length. That's how those two are equal. So arc length is this. Matter of fact, you had a formula last year, S equals R theta. The arc length is equal to radius times theta. Well, since the radius is 1 in the unit circle, the arc length is the angle. The arc length is the radian. Okay? So that's a little thing that we sometimes forget about what radians even are. Okay, so right now, here's what I'm doing. Here's my unit circle. The red is the radian, the arc length. That's what I'm graphing down here. So this length is equal to this length right here. All right? And the blue is equal to the sine. So the blue is that. So as we go along, it's kind of cool to see this. As we go along, the blue is getting bigger, 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 all the way to 1. Then it's getting smaller, 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 down to 0. Now it's negative, down to -1, and then it's here. And we got the sine graph. Okay, so this is just a plotting of the radian arc length versus the y value on the unit circle. And we get the sine curve. Okay? Likewise, if we do cosine, the cosine is the x value. So we're plotting the green length. So it starts out, the green length starts out as a 1, goes down to a 0. Now the green length is out to -1. Then it's back to 0. And then it's back out to 1 again, and then that repeats. Okay? Now tangent's a little harder to show. Tangent, and I don't know if you've thought about this, but tangent is actually the slope of this line. Right? Because what did we say tangent was? Sine divided by cosine. What's sine? The y. What's it? Cosine. The x. Rise over run. Tangent is sine over cosine. The slope of this line is actually the graph of tangent. So look what you get. When you start out, what's the slope of that line? 0. Now it's getting steeper, 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 really steep. What's the slope of a vertical line? Undefined. And sure enough, we have an asymptote right there at pi half. And now that line is now negative. This line right here is negative, okay? But getting more towards 0. And so sure enough, negative, but getting more towards 0. And then we get down here. Now it's a positive line again, and getting steeper and steeper and steeper. And now it's negative again and getting back towards 0. And that's where tangent comes from. Okay, so that's kind of an interesting way of looking at that. All right, let's take a look at these problems right here. So, just want to, basically, your basic trig equation, because here's where this is going to come up this year. We're going to have a problem where we're going to be given a function that's got trig in it. It's got sine or cosine, maybe we can. Usually sine or cosine. We're given a function. We'll do a bunch of calculus to it, da-da-da-da-da, and at some point in the calculus, we'll then have to solve an equation of the function. We'll set it equal to 0 maybe. We'll take the equation, we'll set it equal to 0, we'll have to solve it. And it might be a no calculator problem. That's when you're going to have to rely on this knowledge. Okay? So, if it's a real simple one, it'll look like this. Well, if you've memorized the unit circle, keep in mind now we're between 0 and 2 pi. Where does sine equal 1/2? Pi over 6 and 5 pi over 6. Now, if you've memorized that, you don't have to do any more work. You just solve it, and there you go. Now, if you haven't memorized that, you're not sure where that came from, let's talk about how you could get it. So, draw yourself your unit circle, or just your axis, and you think, okay, 1/2. Well, I remembered my 30-60 triangle has a 1/2 in it. So I'm going to draw my triangle, because I said you got to memorize it. Half right here, that would be pi 6, because I memorized that. So that's one of them. But where else would sine be 1/2? Quadrant 2. 1/2, 1, this would be -3/2. And I remember SOHCAHTOA, opposite over hypotenuse. So sine is 1/2. Now if I put a pi 6 there, what is that? Well, I know if I go all the way around to 180, that's pi, which is 6 pi 6. This is 1 pi 6 short of that, so that's 5 pi 6. So if you have to draw these triangles, do it. Whatever it takes, you've got to be able to come up with that answer. Now, if you can't, is that going to kill you this year? No, it's going to show up from time to time. There'll be one quiz that'll be particularly hard because it's going to have a fair amount of trig on it probably. But it'll keep popping itself up. So the better you know it, the better off you'll be. But we don't, it's not like we do it every time we do a problem, we have to solve one. Okay, then you might get a deal like this where you have to, well, let's go to this one. This is pretty easy. This one you may have to do a little work. You have to subtract the root 3. Then you got to divide by 2. So you get negative root 3 over 2. So again, you just got to remember your triangles, you say it. So some of you may just have that memorized, right? Or you remember your triangles. You say, okay, cosine is, I remember there's a triangle that's got a root 3 over 2 on it. This is cosine, which is my x. So my x has to be negative, so that's negative root 3 over 2, so it's got to go this way. So that would be this triangle, or it would be this triangle. Now this would be a 1/2, or this would be a negative 1/2, because I remember my triangles. And again, that's pi 6 again, because pi 6 is across 1/2. So this would be 5 pi 6 and 7 pi 6 would be my answer to that. Again, if you just could think of the unit circle, just have them memorized, then you have a little less work to do. Or draw your triangle. All right, now this one in the middle. Sometimes we have to get 0 on one side. Whenever you see a power, that's usually what you have to do. So we would subtract cosine over here. We wouldn't want to divide by a cosine. That would be bad here. That would lose a solution if you did that. So we want to subtract the cosine over, and then we want to take out a cosine. Okay. Now later I'll show you how you can solve these on your calculator. You can solve them by using the solve feature. Problem is one of the things that happens when you solve these on your calculator, like say you want to check, see if you're getting them right. We're only looking between 0 and 2 pi. How many solutions actually are there here? Infinite. We could just keep going around and around and around. This is pi 6. Then we could add 2 pi onto it. That'd be 13 pi 6. And then we could add 2 pi again. That'd be 25 pi 6. We could just keep going all day long. Because think about what you're really asking here. You're really asking, where does sine equal 1/2? Well, here's a sine graph. Where does the sine have an output of 1/2? Right there, right there, right there, right there. You see what I mean? It goes forever. At all those places, it has a value of 1/2. All we want is from 0 to 2 pi, which is here to here. So that's why we got pi 6 and 5 pi 6. Okay? All right, anyway, back to this. So we set cosine equal to 0, or this one would be cosine x minus 1 equals 0, so cosine x equals 1. Okay, now for these, you have to remember back to the unit circle. Probably the best way is to remember back to the unit circle. Where does cosine equal 0? Well, that'd be up here, right? Your x. Oh, whoops. At pi halves, your x is 0, or where else? Down here, 3 pi halves. Where does cosine equal 1? Cosine is the x, equals 1 right there. So all right, so cosine would equal 0 when x equals pi halves and 3 pi halves, and cosine x would equal 1 when x equals 0. What about 2 pi? They told not to include, so at x equals 0. So x equals 0, so there's your solutions right there. Now, one last comment, and then I'm going to let you go. You go ahead. Because at pi, it's negative. Yeah, pi would be negative. Okay? Now, one last comment. When you get these 0 and 1, those angles, you can just draw yourself a quick graph. I think that's just about as fast. Unit circles, if you've got the unit circle memorized, that's a pretty fast way to do it. But if I want to know where cosine is 0, I can just sketch myself a quick little cosine graph. It's 0 right there and right there. Pi halves 3 pi halves. And if I want to know where cosine is 1, right back here at 0, and right back here out here at 2 pi. So, and then at -1 right there. But it's 1 at 0 and at 2 pi, we don't include 2 pi. So you can think of the sine and cosine graphs to answer those. You can also think of the unit circle. All right. Okay, I lied. One last comment. On one where you have a squared like this, and there's nothing to factor, you might have to square root, you might get plus or minus. And when you get plus or minus, that's when you might be in all 4 quadrants. So you have to be careful there. Like here, you divide by 4, you get a fourth, you square root, you get 1/2, plus or minus 1/2. Where does sine equal plus or minus 1/2 would be just like number 1 here. Except instead just the top 2 quadrants would be in all 4. So you might have more answers. Okay, those are the things we're talking about. So, with that said, the rest of today, you can, basically this assignment, now, we're not going to turn this in tomorrow, we'll probably turn it in sometime though, because your first priority should be to prepare yourself for the quiz, although like I said, I think we've done a pretty good job of talking about those things and so forth, so maybe you don't have much to do other than just quickly look over some things. So the rest of the time, if you want to get together and work on this worksheet, focus on the trig equations, that's great. If you want to get together and think about the quiz and review those things, or just work on your own and review for the quiz, that's fine. You want to come ask me some things, that's fine too. Okay, answer book here, if you want to look up some old homework problems or something, sitting right here. Mm-hmm. I'm in the grab. Until I get in trouble, then.